Alright, so today we are going to talk about the law of sines. The law of sines will allow us to find angles and sides of non-right triangles. But for our warm-ups, we will work with some right triangles. On number 1, we are solving for x, which is a side. They labeled our reference angle 27 degrees. If that's our angle of reference, x labels which side of the triangle? Opposite side, and the 40 is on the... So which trig function do we want? Sine. Sine of what?
27.
Sine of 27 degrees equals x over 40. To solve this, we would cross multiply, and then there's really nothing to solve because x is already alone now, but we do need to calculate 40 times the sine of 27 degrees. We'll go ahead and round to the nearest tenth.
18.2.
Do we agree with 18.2? If I had come up with an answer like 58.2, how would I know right away that can't be right? Because it's bigger than the hypotenuse, and the hypotenuse has to be the biggest side. Questions about warm-up 1? Okay, on warm-up 2, this time we're trying to find the angle. The 4 represents what side of the triangle? And the 3 is adjacent. So which trig function? Tangent of what? Good. Tangent of x is equal to 4 over 3. In order to find angle measures, we have to use the inverse trig function. So in this case, inverse tangent of 4/3. Let's go ahead and round to the nearest tenth again. What do we get for x? 53.1? Okay. Questions, concerns about our warm-ups? Need more time. Okay, we'll move on. Trig ratios are used for what kind of triangles? Right triangles. The law of sines and cosines are used for non-right triangles. Okay, so SOHCAHTOA, trig ratios we can only use for right triangles. The law of sines and cosines we will use for non-right triangles. The law of sines is an extended proportion. So these blanks represent fraction bars, really. The law of sines says that the sine of, in this triangle at least, angle A over side A, which is when I use a lowercase, is equal to the ratio of the sine of angle B over side B, little b, is equal to the sine of angle C divided by small c side C. You will use the law of sines when you know, well, yes, that's part of it. When you know two sides and the non-included angle, or when you know two angles and the non-included side, or a non-included side. Okay, if you have an included angle between your two sides or an included side between your two angles, you won't have enough information to use the law of sines. Most of the time when we use the law of sines, we are only going to use two of these fractions at a time. So for example, you might only know angle A and side A and angle C. Then you could find side C. We wouldn't need side or angle B at all. So usually we'll use these in pairs of ratios or pairs of fractions. Does that make sense? Might make more sense once we look at some examples. Anybody need more time on this slide? Okay. Then let's try using it. We will round our answers to the nearest tenth. In my opinion, it's helpful to label the diagram. One thing we did not talk about on the last slide, but you should be able to see from how it was labeled, and we have talked about it before. Where would I find side B in this triangle? Opposite from angle B. So side B is opposite angle B. Okay, that means side A that we're looking for is opposite angle A. So I can label those. I'll also go ahead and label the angles that I know. This is not necessarily always a requirement, but I think it helps to organize our thoughts. So if we are looking at the extended proportion we filled in the previous slide up in that box, on this one we are not involving side or angle. Which one are we not using at all? C. We're not involving side or angle C, so we don't have to worry about that last fraction at all. So the sine of angle A, they said, was 22 degrees over A, because we don't know side A, is equal to sine of 49 degrees, that's angle B, over 4.7 for side B. Questions about how we set it up? Okay, how are we going to solve this? Cross multiply. So A is getting multiplied by what? Sine of 49. That's being set equal to 4.7 times sine of 22. In order to get A alone, what will I have to do? Good. Divide both sides by the sine of 49. Now, I would not round anything until you get your final answer. Technically, you could use some parentheses and type all of this into your calculator at one time. Or you could do the top, press enter, and then divide by your denominator. So I'll give you a moment. See what's the easiest way for you to type it into your calculator. If you're going to type it all in at once, for most calculators you would need to put the numerator in parentheses before you press divide by the denominator. Caleb, you have an answer or a question?
A question.
Okay.
You would take 4.7 times sine 22, right? And then divide it?
Mm-hmm. Yep, 4.7 times sine of 22, then divide by sine of 49. Rounded to the nearest tenth. John, what'd you get? 2.3. That's also what I got. Anybody else? Anybody need help getting that? All right, in this one, they did not give us a triangle, at least not in the slideshow, not on your paper either. You could draw one if you want to. You don't necessarily need to. We could just start filling things in. Again, which side and angle did they leave out completely? C. We don't know anything about that last angle. But we could start filling this in. The sine of $50, that's what they gave us for angle A, divided by 14 because that's side A. Okay, so sine of the angle divided by that side is equal to sine of B, angle B is the one we're trying to find, divided by 10. Again, we need to cross multiply. We're taking 14 times sine of B, set equal to 10 times sine of 50. We got a couple things we got to do to get B alone. What's the first thing we have to do? Divide both sides by 14. So that leaves me with the sine of angle B is equal to, you could reduce this fraction if you really want to, 10 over 14, but you don't need to. You could just leave it the same exact way that it is. If you do choose to reduce, do not change the angle next to sine. That cannot get reduced with the 10 or the 14. In order to get angle B all alone, what will we need to do? We can't divide by sine. The inverse sine. We can use inverse sine. So still, to get an angle measure, we are still using inverse trig functions. So inverse sine of this whole big nasty thing. Now, if it were me, you could type the whole fraction into your calculator like you may have done on the last one. So 10 times sine of 50, divide that by 14. And then if it were me, I'd be doing inverse sine of my answer. So inverse sine of my answer. What do we get when we take inverse sine? Rounded to the nearest tenth. 33.2. So we should have gotten the measure of angle B is 33.2 degrees. Are we all familiar with using the answer function on your calculator to plug in your answer from before? Anybody need help getting that in their calculator? Who can tell me the initial ratio or proportion they set up? Akira? Good? Yeah, if you don't know something, it's fine if you use an X instead. I'm not going to be terribly picky about that. The only time it would be an issue is if you're finding multiple things, like multiple sides. All right, questions about our setup? To solve it, we would cross multiply. 20 gets multiplied by sine of 60. B gets multiplied by sine of 40. To get B alone, we need to divide by sine of 40. Make sure you are not trying to reduce or simplify any numbers that are next to trig functions. Even though these are both by sines, we still cannot reduce those. Okay, because sine changes our number significantly. that could all go into your calculator. 20 times the sine of 60 degrees. Divide that by the sine of 40 degrees. If we round to the nearest tenth, what did we get for side B? 26.9. Need more time on this one? If you have not already done so, go ahead and try example 4, finding an angle measure. This time they switched it up a little bit on us, but really it's no different. This time, which side and angle are we not using? A. But it really is going to look the same as what we've been doing. All right, somebody new, tell me the proportion. Ari?
Sine 42 over 16 equals sine C over 12.
Very good. Sine of 42 degrees over 16 is equal to the sine of angle C over 12. Questions about the setup? Okay, again, we cross multiply to solve. 16 times sine of angle C equals 12 times sine of 42. To get C alone, the first thing I need to do is divide both sides by 16. If you wanted to reduce the 12 with the 16, you could, but you do not have to. After that, we would have to use inverse sine to get angle C all alone. Inverse sine of that whole fraction. Again, we should get used to how this would go into our calculator. What did we get rounded to the nearest tenth? 30.1 degrees. Are we all agreeing on that? Anybody have questions, concerns, or need help getting that? 30.1 degrees. An isosceles triangle has a base of 22 inches and a vertex angle of 36 degrees. Find its perimeter to the nearest foot. Got a lot going on in this problem. This is one where I would recommend having a diagram or a triangle. What do we know about isosceles triangles? Okay, because two sides are the same, we also know that two angles are the same. So if these are my two sides that are the same, the base is 22 inches. Is my base one of the congruent sides? No. The congruent sides are called legs. The base is the other one. So no matter which way you drew your triangle, the base is the one that's not congruent to the other two sides. Okay, so if I drew my triangle like this, where would I find the vertex angle? Straight above what? Straight above the base. Opposite the base is the vertex angle. The vertex angle is the one that is not congruent to the other two angles. So my base angles, which are these ones at the bottom for my triangle, the base angles are the ones that are congruent. Now, in order to find another side, we are going to need to know at least one more angle. Since the angles are the same, we'll really know both of them. Who can tell me how to find my missing angles? John?
Subtract 36 from 180 and divide the diameter by 2.
Very good. We know that all these angles add up to 360. So if I subtract, sorry, not 360, 180. If I subtract 36 from 180, what do I get? 144. That has to be evenly divided between my base angles. So I divide that by 2 and I get 72 degrees. So each of these would be 72 degrees. Questions about finding that? Okay. Then we need to find one side. If we find one, we know the other is congruent. I'll call the side on the left side A. You could call it side B or side C. There's really no wrong side to call it in this case. So I need to set up a proportion in order to find side A. Anybody tell me what that proportion would be? Perhaps someone who has not helped me with a problem yet.
Sine 7k over 8 equals sine 36 over 22.
Very good. Now, if you had had sine 36 over 22 on the left, that would have also been fine. Either way, we should be getting the same cross products. Do we have questions about the setup on this? Okay, when we cross multiply, we have a times sine of 36 degrees equals 22 times sine of 72 degrees. To get a alone, we need to divide by the sine of 36. And on A, I don't want to round it just yet. So let's see what we get to a few decimal places. Divided by sine 36. So let's take it to 4 decimal places for now. What do we get for A? 0.5967. Now, I don't want to round it yet because that is not our final answer. I don't like to round anything officially or too much till the very, very end. What would the units on A be? Inches. Okay, so if we know the side that we labeled A, we know the other unknown side is the same, they're congruent. We are asked to find the perimeter, which means we would do what? Add all the sides together. So I'm going to take 35.5967 plus another one, or you could multiply it by 2, plus what else? Plus 22. So what do we get? 0.1934. Is this my final answer? Why not? We have to round it to the nearest foot. Are we even in feet right now? No, we're in inches. How are we going to take this into feet?
Well, 12 inches equals 1 foot.
It does. Divide this by 12. And now is when it would be appropriate to round. What would we get if we round to the nearest foot? This is approximately 8 feet. Now, it's possible we could have rounded a little bit more earlier on and still come to the same conclusion, but to be safe, I would not round very much at all until the very, very end. Questions, concerns? Need more time?